So should we be speaking with the masks on or off?
So I have a question. Are these things being controlled from there? So it can remain on, but it won't cause feedback. Okay. Okay. I'm going to remove this, by the way.
Yeah, maybe we can keep some gap if you want, yeah.
Whoever is doing the naming didn't fix the name.
Yeah.
Balakrishnan.
Yeah.
Didn't change. Should we close this door? There's too much noise coming.
Yeah. Good evening. Should we start or are we waiting?
It's 5:10.
Yeah, okay.
Just go ahead.
Yeah. Good evening, everybody, and welcome to the first of the three panels for COMSNET 2022. I'm Suparna Bhattacharya, and I would like to welcome you on behalf of all the panel co-chairs, Lakshmi Mukund, Dinesh Bhartiya, Tulika Pandey, and myself. So this particular panel today is called Probe the Experts by PhD students. It's a unique spin on a panel discussion where we have invited two renowned experts, Professor Hari Balakrishnan and Dr. C. Mohan. And what we will do here is we turn the tables on the experts, and PhD students, two bright and talented PhD students, Rooji Jain and Ish Kumar, will be asking them questions about their journey and technical accomplishments. So it's my privilege and honor to introduce all the panelists. First of all, I would like to introduce Dr. C. Mohan. So as you know, you hear a lot about his career when he talks about it later on. And if you've looked at the bio, you would see, an incredible list of accomplishments. He has had about 40 years of experience in database systems, in blockchain, in AI, and all of these areas. But I want to make a personal remark here about my association with Dr. Mohan, because it's been going for a long time back. So my memory of Dr. Mohan is when I was working in IBM, then in 1997, I was visiting IBM Melbourne in research, and I remembered seeing a door which was plastered with congratulations. That was a time when Dr. Mohan had been cleared and had become an IBM fellow, and a lot of people were congratulating him, and a lot of funny messages. That was 1997. He had already done seminal work in the area of database systems. If you have worked on database systems, you would have heard about Aries and all the work that he did at that time. That was accomplishment. And the thing is that he didn't stop. It's more than 25 years since then, and he's kept going. He became he has many accomplishments. He became an IEEE fellow, an ACM fellow. He is a distinguished alumnus of IIT Madras. He kept taking those ideas forwards to many products. He didn't shy away from that. He has constantly updated himself on technologies. So he has, one of my interactions with him, I learned about persistent memory or storage class memory from Dr. Mohan. I work in the area of AI, but when I read his talks, he has such depth that I'm learning something new from him each day. And so, I'm going to, leave it, to you all, to Dr. Mohan to mention more about his career. But I also want to mention something more about him. Besides all the accomplishments that he's had, whether it's a 10-year best paper award from, VLDB or the Edgar, Cod award, in addition to that, there is a side of his character which, we experienced when he came to IBM India, becoming a chief scientist for IBM India. And you can see in his resume that he has toured 43 countries giving talks. So the thing is that he has this passion for mentoring and sharing his knowledge and sharing his expertise with a lot of people. And he became an evangelist for technologists. So he used to say that, we give a lot of, get a lot of fame and attention to people who are making money, like entrepreneurs or businessmen. Why not the same kind of thing for technologists? And he really mentored a lot of us. And so if I go back personally in my career, if I remember both in my personal life, the most toughest time and the most times when I had the best of times and, the best of accomplishments, I can remember something that Dr. Mohan said to me during those times. So thank you for that. Now, we have another illustrious panelist here, again, IIT Madras alumnus, and it was actually Dr. Mohan who suggested that we invite Professor Hari Balakrishnan, who is incidentally also an alumnus of IIT Madras and Berkeley, of which he is also a distinguished alumnus of those places. And he also has a huge string of accomplishments. So he has just recently received the Lifetime Achievement Award from SIGMobile, from the SIGMobile community. And one of the things that when we were discussing the panel that, Ish mentioned, that, people aspire to have a paper award which will be withstanding the test of time. Professor Hari has 6 of them. And so he has all of these honors of, he's, IEEE fellow, ACM fellow, distinguished alumnus, and in addition to all of that, again, which is very suitable for this panel, he has won several awards in teaching. And he started one company which is called CMT, which was really trying to improve driving behavior and reduce risk for roadside assistance. And that itself is is serving millions of users in 20 countries. So I think it's a huge honor for us to have you here, Professor Hari. And thank you very much again for joining us at very early morning from your place, from Boston and MIT. And now I want to turn to the 2 bright and talented young panelists and moderators of this panel, to whom I'm going to hand over the floor after this. So we have Rooji Jinan, who is a PhD student. She's a 5th-year PhD student from ISC, where she works on the Robert Bosch Center for Cyber Physical Systems. She's working under the guidance of Dr. Parimal Parag. And what she mentioned was that before joining ISC, she was actually teaching. She was an assistant professor at Christ College of Engineering, affiliated with Kalam Technological University. And then she decided to do her PhD, which her research focuses on low latency in distributed systems and compute systems. She already has been a recipient of 3 PhD fellowship awards. And our second talented student is Ish Kumar Jain, and Ish joins us from San Diego, USA, so you can imagine what the time is there. Thank you very much, Ish, for waking up at night at this odd hour and for putting this together. 3:30 a.m., yes. Yeah, when we start. And he's a 4th-year PhD candidate at the University of California in San Diego. And he has a master's from New York University and a bachelor's degree from IIT Kanpur. He's associated with the Wireless Communication and Sensing Lab and advised by Professor Dinesh Bhardia, who is one of the panel co-chairs. Ish is passionate about new technology in 5G wireless communication, autonomous vehicles, and virtual reality. He has recently built a 28 gigahertz millimeter wave testbed using phased arrays and demonstrated that it can have robust and high-speed multi-beam in practical scenarios. In addition to that, Ish, in addition to publishing papers at top networking conferences such as SIGCOM, NSDI, Mobicom, and IEEE, Ish has also served on the TPC of the Mobicom Student Workshop, and he's also part of the CONEXT Artifact Evaluation Committee. So I hope this will be a huge, great, and engaging panel. So over to you, Rooji and Ish. Thank you very much.
Yeah, thank you so much, Suparna. So this is indeed a great opportunity to be here, to be sharing the stage with such eminent researchers. This is like a dream come true. And so without any delay, let's get into the discussion because it's already late.
Yeah.
So when myself and Ish, when we started discussion about what kind of topics to bring into this panel discussion, so we were actually thinking what kind of topics would interest the ComSnet audience. But then there were certain questions that we ourselves were very curious to ask. Like we got this opportunity to probe such eminent experts. So there were few very interesting questions that we had in our mind. So maybe I will start with one such question.
Okay.
So both of you are very successful researchers,
Yeah.
and some of your works have had very high impact, and they have remained relevant even after 10, 15 years. So my question is this: how do young research scholars like us, how do we choose good research topics so that it would have high impact? And maybe we can start with Dr. Mohan and then move on to Professor Hari.
I wish I had a simple answer for that. By the way, thanks for inviting me. I happen to let people know I'm going to be in town, and then Suparna said, "Hey, why don't you join this panel?" And then I said, "I know nothing about communications." So I said, maybe, I'm inappropriate, but then she said, doesn't matter. So, and then I conned even Hari into waking up early to be part of this. Thanks, Hari. It's really wonderful that you agreed. Of course, Ish is even in a worse shape in terms of being on the West Coast and waking up so early. So I don't think there's any simple answer to this question. I mean, in the presentation that I gave yesterday at Microsoft, and I have a few slides from that one that I thought I'll show at some point. I talk about how, the easy thing to do is to join the bandwagon, right? Oh, currently AI is popular. There was a time when XML was popular. There was a time something else was popular, right? And then you can, go with the flow type of thing. I actually have said in that presentation on my own life history as a case study of, the do's and don'ts and what I was able to do successfully, where I didn't get as much impact as I would have liked, even though the community thought I had published enough papers and I was a big deal guy in whatever, right? Workflow management or something else, or for that matter, even the, effect of non-volatile memories, byte addressable non-volatile memories on database systems. I felt that it didn't see the light of day in terms of whatever results we had being commercialized. So my point is, first of all, stay in any one topic long enough for you to internalize even the problems in the area. Once you internalize the problems, the solutions may not be that hard to come up with. But if you are just trying to, do surface level stuff, keep flipping from one topic to another, you won't have that in-depth kind of feel for the topic. And so it's more important to sometimes even pick topics to work on that might not be the one that everybody else is claiming is a hot topic, and hence you should be working on it. So in my case, at least this Aries topic, concurrency control and recovery in database systems with fine granularity locking and such, nobody at that point was thinking this was worth pursuing. So people thought I was nuts wasting my time when Phil Bernstein and other people had written a book on recovery in database systems. But it turned out a lot of it was all, hokey stuff that had been done. People had not taken the trouble. There were gazillion papers on concurrency control for various kinds of access paths, or index structures, right? B-tree, this, that, and so on. None of them dealt with the real world problems of multi-action transactions, actually implementing these things and making them work with the kind of semantics that SQL requires and such. So it was when I dug deeper into it, in spite of skeptics, even within IBM, right around my own, office and so on, that I finally was able to get something. So, but that's not something that I could have anticipated. But I had this feeling at the end of System R, some people, including Jim Gray and such, Bruce Lindsay, tried to solve this record locking with write-ahead logging problem, and they're not succeeded. But then I said, okay, they went with some baggage based on what System R had certain paradigms that they used in doing their work. And So these guys were not looking at things with a different perspective. And I came without that systema baggage. But I had to do a lot of work in terms of digging through old code to even figure out how they made certain things work, because they had not documented them in terms of research papers and such. So it's something like where you try things and maybe, you know, sometimes you succeed, sometimes you don't. It's also a question, definition of what it means to have impact, right? Some people think impact is writing papers which has gazillion citations, but they may not then think it's important for that thing to be actually implemented and made use of by other people and such. So the attitudes may be different also based on whether you are in Bell Labs or whether you're in IBM Research. Bell Labs guys were more than happy to just write papers. They didn't care about, you know, paying, making sure that their paymasters got something out of it. Unix didn't help, you know, AT&T make money. The rest of the world celebrates those guys. But so that's also another factor as to how you define what it means to have had impact. Is it just awards and such, or product impact, or a combination of the two? So I've always said, if you can do something that's intellectually challenging and also of practical use, which sometimes some of the people, researchers, declare just because it's practically of use, oh, it's just engineering. It's not quote unquote research or innovation. I think that's a BS kind of definition. If you have the ability to work on something that has both possibilities, I would say go for it rather than just working on something that's of theoretical interest or intellectually challenging. Not that I'm saying nobody should ever work on the kind of thing that in the long run might be of value. You know, individual atoms being manipulated one at a time, which was done in my lab. The guy who was doing it didn't know if it ever will be of any practical consequence. I'll shut up. Hari, your turn.
Well, thanks for inviting me to this panel. I'm hearing an echo. Are you all able to hear me? It's good.
Room to hear clearly your voice.
Sorry, what was that?
Yeah, in the room, even I'm having a slight problem hearing your voice clearly.
Okay, I don't know what I should do about it. Is it better now? Hello?
Keep talking and maybe it'll improve as these people.
Okay. So first of all, thank you for inviting me to do this panel. Briefly, I think I agree completely with kind of the way Mohan set it up by saying it's very hard to answer this question. And I would say that you shouldn't overthink it. At least for myself, what I would say is first and foremost, whatever you work on has to be intellectually interesting, especially in graduate school or as a researcher. You know, you've got to, every day you have to keep thinking about whatever problems you're working on. So it better be interesting. So now the question is, how do you go about finding things? I would say that in the community in systems anyway, there's sort of three kinds of people. The first kind who really understand technology trends. I mean, they're really good at seeing where technology is going. And maybe Mohan is one of them. I mean, he knows about persistent memory and hardware trends and all of that. But there are champions in this. I personally never been one of those people. It's been very difficult for me to understand it. So that may not work for everybody. But certainly, if you understand technology trends, you could make some bets about where it's going in the future. The second is there are people who really dig into details of other papers or other systems or algorithms and deeply understand weaknesses in the status quo. These are people with a lot of know-how, and you can develop that know-how by reading a lot. Sometimes that's a good idea, and many students do progress like that. The third, which is sort of the way I have ended up adopting my research mindset, is to think about applications. Either existing applications or just sort of envision applications I'd like to use. And often I find that that motivates research projects. And in many ways, if you're a beginning graduate student, it's probably the easiest, because unless you're in a really good research group, it's kind of really hard to have that know-how and that culture built in the group. Technology trends, you know, you have to have a sort of a mind for that. So I would say that I gave a talk at SIGCOM recently, a keynote there, where I called it Mind the App. And I think there's a lot to be done that way. And I give many, many examples from my projects about thinking about applications. The second point, so that's one, those three attributes, you should think about which of those you're good at, and maybe applications are your cup of tea. It's certainly the barrier to entry is low, and you could go that way. The second related point I'd like to make is with respect to technology trends. Our field changes very rapidly because technology changes rapidly, and assumptions, sometimes the same problem becomes relevant over and over and over again because some technology has changed. But a flip side to it is to ask yourself, what is not going to change? And there are certain things that just don't change. As an example, low latency. This has been for, I don't know, certainly throughout my career, people have always wanted low latency for things. I don't think that's ever going to change. I think in networking, problems related to congestion, I don't think are ever going to change because traffic demands and application mixes are just changing all the time. Resilience, especially as systems become more and more complicated, applications are becoming extremely complicated. Reliability isn't going to change. I mean, probably security and maybe privacy aren't going to change. So those things are never going to change, which means that becomes a fixed point around which you can tackle problems. So maybe these are some hints to get going. But ultimately, whatever you work on, it better be intellectually interesting. And again, as an academic researcher in graduate school, don't be too harsh on yourself. If you find it really interesting, then I'm sure you can work toward writing it up and talking about it in a way that's interesting. And then, let the chips fall where they may. Sometimes it'll succeed, sometimes it won't, but it doesn't matter. You just keep at it.
Much. So as a follow-up to that, I have another question. As young researchers, we often struggle to communicate our research ideas to others. So how do we communicate research effectively? That is, I'm talking about a stage where you actually have to struggle to get venues to speak.
Yeah.
Like at the beginning, when you're not that established, you don't have much visibility. So then how do you even convince your funders that, okay, this is something good enough to be supported?
So first point I want to make along those lines is that people have to recognize it's not enough to do good work. You should also be good with respect to soft skills. So that's something that I don't know, at least in the Eastern way of doing things, where people say, oh, I just sit in my corner, do good work, glory will come to me automatically. I shouldn't seek glory. I shouldn't sort of, go brag about my new invention or whatever and so on. So I keep telling people, all my life, I've never been a manager. 38.5 years in IBM, I got away without becoming a manager. And still I was an IBM executive because I became a fellow in 97, as Suparna was saying. But I had to sell my ideas, especially as a non-manager. In order to have a project where I'm trying to pursue something, I had to convince other people, the regular manager type people who have resources underneath them, to pony up those resources for them to work with me. So all my life, whether I had that fancy title or not, I still had to, at least before the fancy title, I used to report to a first line manager and so on. So I was part of a group and there were resources allocated. But once I became a fellow and I started reporting to the lab director with this fancy title, there was no money associated with that position. So I still had to, convince other people. So in other words, don't think that it's the manager's problem or the team lead's problem to go present material about your individual work or the group's work. So people should be willing to, present, and it doesn't have to be a formal forum. Even within a group, volunteering to give a talk. And as I was saying at one point, getting into new areas and all that, sometimes I'll just say, let me send in a tutorial proposal and then say, oh shucks, now that they've accepted it, I have to get my act together. I have to stand in front of people and not make a fool of myself. So that will then force me to read the papers that I've been just carrying around in my backpack, thinking automatically, osmosis wise, it will get into my head. Now I'm forced to read those things. So I don't think it's at the level of having to convince a funding agency or whatever that you need to go in order to just get opportunities. There are all these, meetups and such post pre-COVID where people could offer to give presentations. So there are more fora now. You could even do a podcast or whatever, right? When we were growing up, we didn't have the luxury of these many different ways of projecting ourselves out for the public to, without any formal, means, blogs and such that are available now, that you could use to put out your point of view. And in so doing, you are forced to have cogent thoughts and cohesive thoughts and write up things in a way that it's not just BSing, just waving your hand and doing stuff, but in a more systematic way. So that's my take. Hari?
Yeah, I don't have a whole lot to add. I would agree with that. I think that speaking and writing are the most important skills with respect to being a successful researcher. There's no denying that. Probably the most important classes I took as an undergraduate were the classes in reading and writing in literature. And I think that, one of the few benefits of the pandemic has been the normalization of remote attendance at meetings and participation, like me being a part of this discussion. I think it is something where you could invite. First of all, every graduate student should try to be part of a group of other students, perhaps in their own institution or perhaps now in other places as well, and have their own group meetings. Don't wait for the professors or the senior people to do. They're too busy. But one of the things that a good advisor should be doing for their students is getting visibility for their students by talking to their colleagues and kind of promoting their work to the point of just saying, hey, listen, invite them to your group meeting. Everybody's got group meetings. So one of the things that can happen now in this Zoom world or video world is, in fact, being a part of another group meeting. And you don't have to worry about whether there's any senior people involved. Just talk to the other graduate students. Usually they're really, really sharp. And I think that practice makes perfect here. The more you speak, you should do it. And then, people talk about having an elevator pitch. I don't know if people travel in elevators anymore, but I think it's a very good idea to have a 1-minute summary of your work and a 3-minute summary and a 5-minute summary of your work to grab people's attention, and then they'll go read something or listen to a podcast or whatever.
Yeah, in fact, I used to say to people, we sometimes think we understand something when we are listening to a talk. The minute you are asked to summarize the talk is when you realize so little of it you understand. It's when you have to get up there and tell somebody else about what you heard, where you, while you were hearing it, thought you fully well understood the thing. You begin to realize, oh shucks, now I can't even say 2 sentences about it. So much for my thinking that I fully understood what the heck this person was saying. So just for that reason alone, forget about presenting your own work. Even summarizing somebody else's thing or a conference report that you give after you went back to your group about what you learned in the conference, those are all opportunities for honing your soft skills and ability to get to the meat of something or whatever and things like that.
Yeah, sure. Thank you. So maybe we should move on to Ish.
Hello, professors, and hello, everyone. I'm really thrilled to be here, though it is 4 a.m. I don't mind waking up at night and be part of this really interesting panel. And I know Professor Hari, from this systems community, and when we attended SIGCOM, when Professor Hari got the award, and it was really thrilling to listen to him. And then I got to know about Dr. Mohan as well. So I will quickly go to my question, and it is like last 2 questions we listened to your comments on how to choose a good research problem which has a good impact, and then we need to publicize and communicate our research ideas to the community. So I want to bring a context here, like from developing nations like in India. How do we develop this kind of like research environment where what points you talk about that people will choose good problems and publicize them. So from the context of India, there are many things which come up, like funding for a project, collaborative environment, or how industry friendly the research is. So can you provide some insight from this context?
Hari, you want to go first?
No, why don't you go for it?
Okay. See, for the longest time, I've sort of been bothered by the research environment in India. I even said at the IISc Centenary Conference, December 2008, when I was asked to be part of the panel on the future directions of the Electrical Sciences Department by Anurag, who then used to be the head of that division, that one of the things that has bothered me about the Indian environment is that, and I sort of, asked around, it's typically professor and then underlings. There was not that much of professors working with one another, kind of collaborative work that goes on at Stanford, MIT, and various places. All the big shots, Hari and Mike Stonebreaker and Stan Zadanik and various people, all big name people, collaboratively work, write papers together. Sam Madden now, sort of the somewhat next gen kind of guy. At Stanford, Jennifer Wiedum, Hector Garcia Molina in the past, and people like that, right? That kind of environment is not there. But this is not as simple, right? Even yesterday and today, I've had these conversations. How many people are willing to go for a PhD? And what's the, if you compare with China, the number of PhDs coming out of China is mind-bogglingly high relative to the population compared to India. So there are many things like that that are problematic. And by the way, this whole business of, research funding is not easy to get and is all bogus, because Department of Science and Technology for a long time has had a lot of money available. And there have been situations where there haven't been enough takers. Indian government even offered individual innovators to get some money to realize prototypes and so on. This is outside of the regular university kind of atmosphere, right? And there weren't enough applications for such things. So I think it's also a question of, in the good old days with Y2K and this and that, there was easy money to be had. So while the brain drain, quote unquote, had reduced, at least in the IITs, in terms of what percentage of people from India went off to US for PhDs, that didn't mean that they necessarily stayed on in India and did their PhDs. They all took up, high paying jobs, or they went into IIMs and such. So what I've been telling people is that it's not any one thing that's going to change it. The whole ecosystem has to change. And this whole notion of management ladder versus technical ladder, I'm thinking outside of university atmosphere. People, researchers becoming faculty members is one path, but I also want the industrial research kind of activities to go, multifold increase and all that. So if you look at it that way, I've had a hard time when I was the IBM India chief scientist. One of the things that I was trying to promote, as Suparna was saying, was this idea of technical leaders being treated as role models, not just the, Nandan Nilekanis and such people who made a lot of money through companies and such. But, occasionally, CNR Rao was held up as a model. But if you look at the popular press and so on, they don't celebrate enough people who are, pure techies, who have done some great deal of things and such. So it's all that stuff that has to change. People, looking at your business card and noticing that you don't have the title manager, then claiming that you haven't made it in life. This whole societal kind of BS, as well as, money being something that everybody knows about, what your salary is, and then that becomes the sole determinant of who is better than who. If I make a few paise more than Suparna, I'm thought of as being smarter than her. That's that kind of thinking, or managers thinking they should make more money than everybody underneath them just because they are manager of such people, is another dimension along which there is a lot of change that needs to be made.
Professor Hari?
Yeah, I'm afraid I don't really have a first-hand understanding in computer science of what the challenges are for especially academic researchers in India. But I know there are pockets or areas where there's a lot of truly world-class work being done. Some of them tend to be more theoretical. I think Mohan's point got me thinking that, sometimes you need critical mass. And I think the idea of professors collaborating at a given university or across universities to create something bigger and be more supportive of each other might be a very good, might be the missing thing. Because one of the things that happens in research communities is you start working on something, and who's to say whether it's important or not important. And sometimes nobody knows, right, what the impact is going to be down the line. And I think one of the advantages of especially slightly more senior, they don't have to be senior faculty, like even assistant professors, getting together to create something bigger than the individual, where there's enough success, enough credit to go around, and truly, collaborative, at least in the visioning standpoint, right? Like we are all aiming to, for example, build something or the other, whatever it might be, right? Millimeter wave technologies or something. I think that critical mass then becomes, they start talking about it more and more. The rest of the community starts paying attention to it. And I think the importance of early stage evangelizing ideas and having some conviction around it is good. And the other thing is that when they start collaborating, they can actually genuinely say, listen, I'm not sure that's such a good idea versus this other idea. Let's work together to make it better. And I think the importance of that sounding board is very valuable. One can get that sounding board from the graduate students, and it's possible, and I don't know, I have not experienced this firsthand, but I think it's possible that it used to be certainly that in India, the graduate students are a little too deferential to their professors. They should realize they know as little or as much about a topic as their professors in many cases, if it's genuinely research. And really don't worry about, in football, they say play the ball, not the man. Sometimes they say play the man, not the ball. The idea being, don't worry about who the man is or the woman is, right? Just the idea matters. So if you think the idea is good or bad, you go after the idea. Never attack the person, attack the idea, or at least try to improve the idea. So I think maybe the younger folks in India might be too differential. It's probably not true anymore, which is good. But I'm very much, I agree with Mohan. I had not thought about this, but I think the idea of more senior people collaborating, if it's happening, that's good. That'll probably make a big difference.
Yeah, what I've been told is that that was changing and so on, even when I was raising this point in 2008. But I'm still not sure, there is enough of it happening. But I agree with your other point, which is this business of questioning senior people. In fact, that's one of the things I constantly talk about in my presentation, about how I didn't take at face value what Bruce Lindsay was asserting and all that when I joined IBM, and also later with respect to this Aries stuff that happened. Some of these people saying, hey, why are you, addressing this point, which I believe is all solved problem, or we try to solve it, we couldn't solve it, so who are you to think that you can solve it? Kind of way of trying to, push you away from addressing a certain topic. So definitely that needs to be this idea of asking very, the devil is in the details type of thing, right? Analyze stuff and make others who claim certain things give proof, or give more evidence as to why what they think is the right way of doing things, or this direction is better than that direction, to give you more justification, not take it at face value just because they are senior people, is the sort of thing that also definitely needs to increase. But also, with respect to these resources and such, with all this open source stuff that has happened over the last many decades, that excuse even for software people is no longer there. The ability to use, packages that are out there where you don't need to pay Oracle or IBM money to buy their system, to do something on top to, produce something that's more exciting. And hence you are saying, hey, I have to make do with some silly thing that I just handcraft myself, is not anymore a good justification, because there's so much out there that you can make use of to build something more substantial on top without getting lost in doing this basic stuff over and over.
Yeah, I agree. I mean, from what I've gathered, I spent some time in IIT Madras and talking to people there. I think research-wise, I don't think there's any shortfall. I think that, in fact, given also that many of the graduate students are paid for on other, government programs and so on. I actually think they seem to be as well resourced as I am or other faculty at other universities are. But it may be that, I want to put a little bit of the onus or pressure here back onto the graduate students and postdocs. I think they have to take more initiative if they're not taking it. Don't be passive. Don't wait for somebody to tell you what to work on. Just, realize that we're all in research, we're all in a fog. Maybe the senior people have a slightly brighter light, but they may be looking in the wrong place. So you should take the initiative.
And also contributing to open source and trying out your ideas, and not just be happy with simulation and modeling and analytics and just move on to the next paper. Try to make your things available to other people so that they can play with it and such. The kinds of things that Wisconsin and MIT and various places have done, as the idea of, even if it's not open source, providing stuff for others to play with, and then having to deal with something's not working and such. While it might take time, it's still worth it. I don't know how much of that's happening in India. I don't think a whole lot of it is actually happening. Even if they build something, the idea of making it available for outsiders to then do something with it and give feedback and such. Like you said before, this whole idea of application-driven innovation is what you were at one point saying as one way of addressing new problems, or measuring impact and things like that, or getting something concrete that's of practical value and such. For all of that to happen, you do need to make your thing available for others to play with, if you yourself are not able to try out different applications by building them all yourself or within your university or whatever the unit is.
Mohan, one thing about, just you mentioned China, but one thing I've observed about some of the recent last 5 years papers coming out of China are at the top conferences are how many people are involved in each paper. They have small armies of, I have to assume that many of them are graduate students. And I just don't think, practically speaking, that's easy at the moment in India, given the relatively small numbers of students in PhD programs, or even for that matter, a far diminished number of Indian students who apply to PhD programs abroad, right? It's much lower than it used to be. And compared to China, it's that gap is diminishing.
That's where I'm saying the whole ecosystem needs to change. Whatever it is that's preventing more people from getting into PhD programs, that has to change. Societal pressure, or not care. I don't care about that kind of way of making a living, all that.
Yeah, I agree with all of that. What I'm saying is that, though, it might be good to strategically pick and choose your battles. If you want to take on a massive open source system release, right? It usually requires 6-7 people working on it. I mean, at least all the projects I'm involved with, you've had to devote substantial resource attention to this one project and build it out. And I don't know practically how many groups in India in the networking or systems area have that type of critical mass. It might not be easy to get there. And so,
by the way, that topic has been brought up even in the US. The smaller universities, which are not like the MITs and the Stanfords, have made that same point, that they can't do what you guys do in these fancy universities because they don't have the critical mass.
They don't. So I think that so one has to sort of pick and choose. And so one approach to doing that is to take on, start with some open source software that you want to try your research idea in. There might be things to do. And there's some success examples of this, of small groups, taking things in the Linux kernel and making small changes or making changes to it. And there are ways to do it, but it requires a little bit of thinking. The other possibility is, but I agree that if there are faculty collaborating together, it actually makes a big impact, because I think you're no longer the lone small group fighting. You need to build up slightly bigger groups in certain problems.
Where the collaborative thing also comes into play, right? If you don't sort of isolate yourself in a single organization and don't want to work with other people, this problem you're pointing out will be a problem. But if you are into the game of saying, the sum of the parts is better than the individual ones and such, then you can get to that stage where you are able to contribute. Even Suparna has done a number of things in this Linux kernel thing, right? So she managed to do all that almost single-handedly, right? So it's a matter of what you choose to focus on. Do you count the number of papers and such as the metric for defining you have had impact, or do you take on this, greater thing of actually making your ideas become real and let a bunch of people use it? How many downloads and all that as a measure of impact?
Yeah, I mean, I would say it's, if people should define their own metrics, whatever gives them the greatest satisfaction. And I mean, again, both of them are very valuable. I mean, great ideas are also very valuable. So I would certainly say that it's not about the number of papers that one gets published. With respect to choice of problems is really what it is. I mean, if you have two students working on something, and taking on some massive new implementation project might not be a particularly practical thing to be doing, but being strategic about how you get your ideas out there in software or other ways, I think is important to bear in mind.
Thank you, Professor. It was a really good discussion. And as Dr. Mohan once mentioned, like there's this in India, brain drain is generally considered in a negative connotation that people go abroad for higher studies and jobs. But I think these are young people, when they see the world, as we call it, and when they come back to India and they can bring these changes to the organization level, and also all the topics that you talk about, the collaborative environment, the industry friendly. So yeah, I wish more people would come forward and bring the research culture in India better, and I hope to do that. So I will put the stage back to Rooji.
So, as you actually mentioned just before, so young researchers, they actually have two paths to choose. You mentioned earlier, like you can get into academics, or you could actually choose a path of industrial researchers. So can you share your perspectives on the difference between these two? Like if I am to choose academic research or industrial research, why should I choose either of them? Like how do I know like I would fit in there, I would fit in academic research or...
Yeah. So first of all, the typical academic research also involves teaching. So yeah, there are some specialist positions where you can be a full-time researcher in an academic environment, but the average case is not that, right? So if you don't have any aptitude towards teaching and dealing with students and so on, pretty much your choice will be then non-academic research, right? That doesn't necessarily mean it's industrial research. You could, in the US at least, the national labs and such are there. In India, it's to a lesser extent, but there are still such possibilities in India. They've become more, I would say, compared to when I left India, 44 years ago. 77 is when I finished my BTech. And that apart, the general discussion that you will hear is people will say, oh, I have all the freedom in the world to do whatever I want in academic research. And I consider that a bogus claim, because I've had this argument with Mohammed Gouda at UT Austin, give me a break. If you want to get promotions at the university and so on, you are still bound by a bunch of things that the deans and the others who are giving you reference letters will hype about, and they won't hype about certain things that you might think are exciting things to work on just because it's intellectually exciting. So the once you are in the funding game, you have to apply for funds, and that also might be a metric based on which the university might want to reward you, how much money you brought in, and hence a whole bunch of students could be supported and so on. So now guess what? The funding agencies are to a large extent deciding what the hot topics are and what should be the focus. So in many such ways, there are bounds to what you can do, unless of course you are at a place where you can't even say as an assistant professor, if you don't get tenure, you are still okay with, doing whatever you want. They'll actually boot you out if you don't get tenure. So maybe if as a full professor, you think in some universities, they can't get rid of you, so you can do whatever you want, and you don't care to get any more awards or this or that or whatever. Again, that's, I think, a fringe case. I don't think that's the normal case to think about. So the thing that people will say is, oh, in an industrial research lab environment, you're going to be more constrained by whatever it is that the management there thinks should be the focus, and over time that might change. You might not be happy about having to change because the organizational priorities changed and such. So in my case, I didn't even apply to academic positions as I was finishing my PhD, because I felt my PhD thesis work was all bogus. Some, silly algorithms I cooked up. I didn't even implement any of that. Yeah, I got papers in some fancy places and all that, but I didn't have a personal satisfaction of having gotten to know about real systems and such. This was the atmosphere in UT Austin, at least with respect to my professor and so on at that time. And so I really wanted to dirty my hands and get to know about real systems. So I said, even as a fallback thing, I'm not going to apply to universities. And I had not been a TA except for one semester. And even then, only because the professor ran out of money for RA, research assistantship versus teaching assistantship. And I had to just deal with the, labs kind of thing. I mean, assignments and so on. I didn't have to actually get up in the class and give lectures and so on, right? So I also wasn't sure that I would enjoy teaching very basic stuff. And I love giving talks, but not necessarily on the most mundane things and setting up, exams and so on and so on. So for that reason also, I wasn't enamored of wanting to, upfront without even having that experience, go in for the academic life. So I'll stop here.
Well, I mean, I think, I've had students, I've had about 25 PhD students and 10 postdocs finish. And so if I look at where they landed, it's probably 50-50 with respect to industry and academia. And among the ones who are in industry, it's probably within that, maybe 60-40 or 70-30 startups to larger companies. And I think one of the things that has changed in the last 20 years, 25 years, maybe even 30 years, has been that the number of large companies with genuine research labs, genuinely doing research, has come down. It doesn't mean that the research is uninteresting. It just means that it's a little bit more focused around product or focused around whatever the mission of the company might be. And that may not be a bad thing for the larger companies. Ultimately, it's a little bit of a choice. So the question you might be asking is, how do you go about making that choice? I think that academia is best suited. I don't think the teaching part of it is that much of an issue. I think it's actually quite manageable and really fun in most cases. But I think that the best way to think about it is, if you enjoy working with younger students at the start of their careers, especially the graduate students, then academia is a good place to be. You are independent in that you have to go figure out what to work on, raise the money for it, sell the ideas. It's not that different from anything else. I mean, Mohan, I'm sure, had to sell his ideas with an IBM. It's probably relentless at that. He's very good at marketing, right? That is important for success in any of these careers. You're trying to do something and sell why what you're doing is good. I think evangelizing and being able to articulate why what you're working on is important is going to matter in most of these research-oriented professions, but it's especially critical in academia. And you also have to motivate the graduate students. So I think that the biggest opportunity or advantage of being an academic is the ability to work with students at the start of their career. Often have great ideas or can be made to have great ideas. It's also the biggest challenge because they are younger, and you get to mentor. You have to kind of make sure that your group's culture is good and all of that. So it's like running a really small enterprise within a larger
Manager
enterprise.
too in that process.
Say that again.
You are a manager in that environment where you are managing this group of people. So being an individual contributor and a professor is a bit harder to do, is one of the ways of looking at it, right?
Yeah, I mean, I think that this distinction between a manager and individual contributor, I think, is more stark in industry. I think that, in especially, I feel that at least in academic research, it's there are some people who are pure managers, but I think that there's a lot of there's an intermediate. I think in industry they would call it a technical lead or an architect. So I think that's often the role of in certain projects, the role of the more senior investigator or professor. So I think there's a little bit of element of management, but it's not as uh, it's not as rigorous as it might be in a company where there's a lot of process. So yeah,
Hari, just to expand on that, the point I was trying to make was that you, as the professor that's dealing with a bunch of students, you have to worry about making sure that each of the students could work on something that can be justified as their contribution for their PhD work. So this divvying up of this project work into pieces in a way where you also have to deal with these students, I don't know, fighting with each other or whatever and so on about, hey, that's my topic and this is somebody else's topic and so on. It's more of that also that you have to deal with than maybe a pure technical lead in a industrial research kind of environment.
Absolutely.
Yeah,
absolutely.
That's
absolutely.
all.
Yeah.
And also, applying for grants and such and having to then think about the project management of, in 5 years or 4 years, what am I going to give and so on, what the, what do you call it, the milestones are along the way, depending on the funding agency, right? Whether it's a DARPA grant or it's an NSF grant, some of these things vary.
Yeah, you're absolutely right. And I think that I actually think it's not bad training for someone who may want to or may have the opportunity to start a company in the future, because it's actually very similar in terms of skills. Now, that said, many academics don't start companies because it's not their cup of tea, or it also, starting company requires a lot of other things you have to deal with. But I don't think it's that one is better than the other. I think that they're a little bit different, and there's paths to success in both ways, and there's paths to frustration in both.
So, Professor Hari, I would like to ask, since you mentioned about starting a company, would you tell us a story about your startup? Like, what brings most excited about it, and how do you manage both academic and industry life?
Yeah, let me. So the startup came out of research that I had done with my students and with my collaborator Sam Madden. We started a project called Cartel in 2004, where the idea we had was very application inspired. I had moved from Cambridge into the suburbs, and I'd been noticing that over time my commute was getting worse and worse and worse. And I mean, it's just a very simple observation. So Sam had just joined from Berkeley, and I think I just got tenure with at MIT. And I said, listen, I've been doing this work on sensor computing, and he's been doing sensor networks. I said, let's put sensors on cars and just measure what's happening. Let's understand why. And also, I was noticing that in the Boston area, roads were getting worse and worse, especially in the winter. And I was like, how bad is this? Why is this just getting delayed? So you have to remember 2004, 2005 was before iPhones and Androids and so on. So we built some embedded devices and put some stuff with Nokia phones and just started getting a lot of interesting data. And then we had some really good students and postdocs who joined our project in time. And one of them had a brilliant idea, Jacob Erickson, he's at Chicago now. He had this great idea. Let's just partner with some local taxi companies to scale this out. So, here's this group that we're building this stuff. And I got to say something relevant here, which is that a lot of the systems work we did that I found intellectually really interesting was very cool. But what mattered in the end with respect to what became impactful was what we were able to do with the data, not how we went about building the system to collect the data. So I think we have to have an open mind. So long story short, we ended up being written up in various newspapers like the Wall Street Journal and the Boston Globe, because we built this thing called the Pothole Patrol, where every day we would have these taxis go around and we would do what today would be called machine learning, but at the time we just called it algorithms for taking sensor data, accelerometer data, and GPS data to map potholes and bad road conditions in the Boston area. And we would put a ranking list of the top 20 potholes that we found today. And it was just a website. So the newspapers all got very interested in it. And there were big articles written. So then the recession hit, and I thought, we've got some academic best paper awards, and the press is writing about it. So this must be useful. So, and then I started learning about road safety. I was looking at road hazards and transportation and traffic as the possible business case, but just by reading I learned that insurance companies were building expensive devices or wanting expensive devices to monitor driving for deciding on how to set premiums. And I started learning about road safety. And the more I learned about it, the more I found that about 94% of road crashes were because people were just not paying attention or were bad drivers. So, and by then we had transformed what we've been doing to work on iPhones and smartphones that just started coming out, right? So that's sort of what happened. The idea was to go to insurance companies and tell them, look, you don't need expensive hardware. IoT technologies are becoming really low cost. We can build those. And moreover, we can do everything on phones, or a lot of what you're doing on just commodity phones. So you place this bet about the future. It takes a while to unfold. You have to have some luck. But sometimes luck comes about if you just keep working hard at it. So that's sort of the journey. And it was based on kind of this research that was taking noisy sensor data and drawing inferences about mobility. And then we applied it to safety.
Yeah, thank you very much, Professor.
Wait, Ish, did you ask him how he balanced his academic responsibilities? I don't think he addressed that.
Yeah, yeah, intellectually, I try to do both. I have a group of graduate students. I'm also very heavily involved in my company, which has now got 400 people, and so it's a very active engagement for me. I mean, I really enjoy doing it, and the company right now, we've moved. It has always been very close to MIT, and right now it's on the MIT campus. The MIT has a building now with housing a bunch of companies, so we're on campus. So it's very close to my MIT office, and I, kind of spend time in both places. Yeah, I don't know that I have a better secret to balance. I will say that it's, at least at my company, it's very, it's a massive collaboration, right? I have not only excellent engineers and product people and salespeople and so on, but an amazingly strong management team. So one of the key things is to learn what not to do. So, especially in a company, most decisions don't need a founder's attention. You want to empower other people to make the decisions and just tell you what they've done. And you ask a few benign questions or probing questions, and you trust them. So the key to a successful enterprise is making sure your team is strong and you hire the best people that you can and empower them to make the decisions, because the best people want to be in positions where they make decisions, whether it be management decisions or technical decisions. So I think that learning what not to get involved in is a key aspect of being successful at running a company.
Yeah, that was really great insight. Now, I think honoring the time, we'll ask Rooji to ask maybe last one or two questions and conclude it.
So another one of my questions is, so according to some recent studies by UNESCO, the world's researchers, if we check the gender diversity, then only nearly like less than 30% of them are women. So what are your perspectives on improving gender diversity in a research space? Do you think there are any gender-specific challenges in this career?
Good question. So in fact, one of the things that I would like to point out in the context of AI, at least, Stanford has an AI institute, and they put out an annual report. I highly recommend that you guys go take a look at it. I refer to these things in my AI past, present, and future presentations that gives more detailed information on this kind of thing, as well as, how many of the people who do PhDs that are foreign people that come into the US then stay on in the US. And also the other point that Hari made before about more of the research or research-like things are being done in industry. That's also something that this report points out. Where do these AI PhD people, after they finish their studies, land up? Within academia versus non-academia. In the non-academia part, do they go into traditional research labs like IBM Research, this, that, or do they go into startups and so on? And if you look at even some theoretical people coming out of Stanford for quite a while now, they've even gotten into just companies that are not even having anything that they call research in them. So coming back, in India, of course, at the lower levels, in terms of bachelor's level programs, it's almost quite 50-50. I've been amazed going to, of all places, Madurai, Tyagarajar College of Engineering. I was there on Teachers' Day one time. I was amazed that it was 50-50 almost. Of course, they were all sitting separated. I don't know why. The women on one side and the men on the other side. But you go to any US university, it's not anywhere as good as in India. And even in companies, when I was the IBM India chief scientist, this was one of the things that we struggled with. At the technical levels, at the lower levels, it'll be pretty balanced. But as you move up, you'll find that there are less and less of women than men. If at all, there are that many people in the technical ladder. Everybody and his uncle wanted to become a manager because that's what was appreciated by the janta out there or whatever, right? Or they thought it was easier to move up the management ladder than the technical ladder. So given that, at least in the Indian context, we have talked about how the number of people who choose to even go for PhD is very low. And that's already a fundamental problem, ignoring the gender part of this. I don't know whether there is anything specifically about women that is an issue, that's something, more generic or whatever. The thing that has been discussed before with respect to this, as you move up the ladder, there are lesser number of women. That, of course, at least in the Indian context, has been attributed to women still having to take on more of the burden of bringing up kids, and that then makes them think maybe they shouldn't, be on the technical side. Also, because a lot of times they have to interact with people abroad, and they think that they'll have less of a flexible schedule. But if they move up the management chain, they seem to think that they don't have to be awake in the middle of the night to interact with techies in America or wherever the other groups are that are part of a multinational kind of company. So I mean, the Indian government, by the way, to their credit, way back in 2008 or 9, when I attended the only time the Indian Science Congress, had set aside money for 50 plus women who had gotten out of the work stream because of family, whatever reasons, to bring them back easily. Money was set aside by the Department of Science and Technology for them to just apply. All they had to do was have a lab in which they could go and do work. They didn't have to be employees of the university's lab or some industrial research lab, but they should be allowed to go work there. At least to that extent, they had to show that they managed to get somebody's blessing. And then there was money, and guess what? There weren't enough takers. At least this was the story when I first encountered in this National Science Congress, DST people coming and presenting this kind of thing. So to some extent, I think it's this, resource question that used to be used as a lame excuse in the past is not, I believe, to my limited knowledge of the current state of affairs, a real good excuse to be given for some of the discrepancies. But the more societal thing about whether women being in senior technical positions being celebrated or not, I mean, we've seen it, right, in the context of these satellites, whatever, Chandrayaan or whatever, there was this group of women who were, celebrated like crazy because they were they were in very senior positions and so on. So I really don't have a simple answer for you.
Professor Hari, if you could please share your opinion.
Yeah. I mean, I think that first and foremost, I think it's important to look at the derivative of that 30% number, whatever that number might be. Is it trending in the correct direction, and how fast is it trending? So that's the first comment. And I don't know the answer. I would hope that it's getting better and better, but the derivative is more important to look at and see whether it's kind of stagnating or how's the shape. First. Second, I think at the undergraduate level at many top schools now around the world, I think we are seeing more equalization in terms of in the technical fields. It's still not completely 50-50. I know MIT is 50% undergraduate women now, and we're mostly a technical school, but I don't know exactly what it is in computer science. I don't remember. But I do think the ratio is getting closer to 1. So now the question is what happens in the research side. So I think I would say that from the perspective of a research career, probably first and foremost, I think has to be that it has to become childcare support has to just become completely normalized. So it just needs to be established that you don't have to worry about childcare, no matter what you do in research. And I think that this is something that I don't know how relevant it is in India, but certainly in other countries, including the US, this always is at top of mind for people, and it's natural. And I don't think it's a specifically woman issue alone, though primarily it is. It's an issue for men as well, but much more so for women. So I think first and foremost, I think it shouldn't be a discussion. Like universities should just have childcare available for women. Companies should just have it available or pay for it. Just it's not part of your regular salary. You get paid. You get funded to take care of that, and that might be a benefit that is first and foremost helpful. The second is for academics. I think the way in which tenure and promotions work with that time frame has to just be flexible. And more important than what the universities do, which they do, people writing letters. It's not about the deans writing letters and so on. It's people in the community, like the rest of us, writing letters for younger, candidates. We shouldn't look at, okay, when did the person get their PhD, and then count the number of years and have an expectation of output. Because it doesn't matter how many years it was. You come up for tenure, there is a body of work that you need. How does it matter whether it was 3 years or 7 years or 10 years? It doesn't matter. The family, maybe somebody had elderly parents, maybe somebody had young kids. So the culture of people like us writing letters, like Mohan, me, etc., writing letters, we got to stop looking at when the person got a PhD. It doesn't matter. What matters is at the time they come up for promotion, what is the body of work? So I think that those two, and they're easy to change. I'm not saying easy to change. They are changeable, but it's about our mindset. And I think that if we are flexible with respect to ultimately, children and care for children and the thing around it, I think it'll see an improvement in the numbers. But I feel like those are the two most important things we could actionably take.
The CRA probably tracks quite a bit all these sorts of numbers, the Computer Research Association, which is the heads of computer science departments at the universities, as well as in some of the research lab heads and so on. They have traditionally tracked these numbers, how many people go for undergrad in computer science, and then master's, PhD, and various ways of slicing and dicing that data in terms of nationalities and gender and so on. So, yeah, but it's a very good point that Hari made about the way we all look at things. This productivity rate as a number of years.
Yeah, I think it's like I never understand why that matters. How does it matter? Because the person is being promoted to a certain position. So what if it took somebody X years versus Y years? Are they qualified for that position based on the work is the only thing that should matter. And nowadays, promotion letter, cover letters mention things like this. The problem is guys like us, I'll include, we never read those things. We just, the problem with senior people is we assume we know how we should write these things. We don't change fast enough, and we should change.
Last night, a person here was complaining bitterly because somebody with a large number of journal papers who wanted to become an assistant professor in an Indian university, even IIT, was told, guess what? You don't qualify because you are more than 36 years old or something. Apparently, there's a upper bound on how old you can be when you are named an assistant professor. I thought this
Yeah,
was
I mean,
mind-bogglingly stupid.
yeah, I mean, this is probably somewhat relevant here, but I think that I would hope that the Indian rules are changing, because my mother graduated with her PhD, and for 10 years she wasn't really able to work because of various government rules regarding employment, and she's written about this, and I've posted things about it on my LinkedIn as well. So I mean, I would hope things are a lot better now than they were, but it doesn't mean we should stop fighting to get it to be completely at
Apparently,
parity.
the IIT directors and all said, sorry, to get an exception, I have to do something and I'm not willing to do it. Maybe the person is in the audience, the one who was most annoyed about this, that this younger person, but not too young, not young enough, was trying to get 36.
Yeah, but in any case, I think that both the community and the rules just need to be more flexible and understanding, and not look at metrics like the rate of productivity, but view it more as a state function, not a path function.
Thank you so much. That was really good points that came out from that discussion. So I just have one more question, and
It's
this is
6:24 and I don't know whether the audience wants to ask questions. So.
yeah. Can I have like one more question, Suparna? Is it okay, or should we go to the? Do we have some questions from the audience? We can take one or two questions. Yeah, then maybe I can.
There's somebody. Oh, now suddenly more hands are going up simultaneously.
Thank you. Yeah, so good evening, sir. And I hope it's good morning there, Hari, sir. So the topic was really interesting, but I have one question to ask to both of you. So, sir, both of you talked about the application-driven research. So, sir, here I would like to ask is that in the PhD journey, all having different research area, different journey. So, sir, like all of us cannot have the opportunity to uh, make research that is having the real-time applications in the real world. Many of us may do the theoretical research, but when it comes to about the judging which one is best, which one is not, I see the probability of selecting which is having the practical implementation. So now, sir, the question is that we all are not that much privileged to get the grants for any companies or any industry to make such kind of practical demonstration or implementation of that. So, sir, my question is that how can we make some impact through the theoretical research? So, in a PhD student so how it is possible?
Hari, I'll let you first answer.
Thank you, sir.
Yeah, it's interesting. I mean, when you say theoretical research, the question is, are you talking about research in theoretical computer science or applied math, or are you talking about theoretical work in a systems area?
Referring to AI, by the way.
So you're talking about AI?
Computational systems and so.
Well, one thing I've observed on the theory community, or even the theoretical AI community, is they generally have a set of questions that the community is interested in, right? If you talk to 10 people or 20 people in a certain theoretical area, they all generally have agreement on what are the important questions in their field. And of course, that evolves over time. Somebody comes up with a creative idea, a new question, etc. But I actually feel like in those areas, it's a little bit, the problems are out there already in many cases, and you're taking an angle on it. Whereas in the more systems areas, you're creating problems. The asking these questions is, I mean, not that in theory it's not valuable, it is certainly valuable, but I think in the systems area, 50% of many of these research projects is asking the right questions. So I think there's a certain value to that. So what I would say is, whatever you find interesting about the problem you work on, try to explain why that's interesting to you to other people. Don't worry about the solution yet. Worry about why is that question the interesting, why is that motivating you? And I think that will make the case to whoever is reading about it and get people excited, or at least interested in what you're working on.
Let me try to rephrase your question because I'm still not sure whether that's the thing that you are asking about. I thought you said your particular university environment or whatever might be such that you don't have the luxury of, while you are doing your PhD work, be able to work with industrial people, be they, IBM research people or whatever, or some company, I don't know, Reliance or this or that, where you will be able to try out your ideas in a practical setting. And so you then wanted to know, how can you have a impactful kind of work? Was that still while doing your PhD or post your PhD? That part I couldn't figure out from your question.
Yes, sir. Like you correctly identified my question, and during my PhD.
During your PhD. So the thing that I've said in the past with respect to at least the US environment is to go and do internships. This is a point where some university professors are greedy. They don't want their students going and doing internships because they want to use them as, I'm going to make it a silly kind of point, a cheap labor that they want to hoard and make them do their thing during the summer rather than going and doing industrial internships. Now your question then might be, oh, my university is not considered top ranked or whatever, that these guys who do have internship possibilities don't necessarily take me as an intern, which could still be an issue. But in general, if you are not lucky enough, some of the things that people have done in India are the, second tier, third tier university people will go and do an internship even in IITs. There have been these sorts of things that people have done. And there they get to interact with people who are luckier, or whatever you want to call it, where they are working on what are considered more important problems or impactful problems. So that's another route that certain people have taken in India, and I'm well aware of that, right? Even bachelor's people, forget about PhDs. So beyond that, I don't think there's any simple solution to your problem that I can think of, except for all the points that have already been made, which is you could make use of some open source software, not waste your time building some basic stuff yourself, even if you don't have money, as I said, and hence you can't go for commercial software to build your thing on. Life now is a lot easier in a sense. So you do have to, of course, take the trouble to understand what this thing that's out there is having as its feature set and how it will be merging with whatever it is that you want to do on top and such.
Yeah, I think I did have a question, but it's time. So I just wanted to thank, this is Warren from Carnegie Mellon. I just wanted to thank both of you for the amazing discussion. It was so very insightful, and it's wonderful to hear from the both of you.
Oh, most welcome. Thank you for the nice words.
Hey, Swaran.
Hey, Harry.
Yeah. So do you want to still ask your question? She had one banked question. Unless somebody else wants to ask.
Yeah,
Oh.
I think we have to move to the next keynote. So
Yeah.
Oh, okay.
There is
Oh,
a next session
Oh,
at
yeah,
6:30.
ending the
so,
session. Okay.
Yeah.
Thank you, everybody. Thanks for your patience. Thanks, Hari. Thanks,
Yeah,
Ish.
thank you. Thanks for
Yeah,
inviting me.
thank you.